All right, this video is going to cover compound interest. So interest that's paid on the principal plus any interest that was earned previously is called compound interest. Okay, that's compound interest. So after a certain period, the interest so far will be credited or added back to your account, and then the principal plus the interest will now earn interest during the next time they calculate the interest. Okay. So the interest can be added back to your account at time intervals other than just 1 year. So it can be done semi-annually. So that means they're going to calculate the interest twice during the year, and each time add it back to your account before they calculate the interest. They could do it quarterly. That would be 4 times. So semi-annually means twice in the year. And I'm using an N here. I'd like for you to write that on your sheet because in the formula, N will be how many times the interest is calculated in a year. Quarterly would be N equal 4, monthly would be 12 times a year, and daily would be 365 times, right? This time interval is called the compounding period or just period. Compounding period or the period, okay? So there's a different formula that we use when we're dealing with compound interest problems, but a lot of the letters are the same. Like the A is still future value or future amount. The P is still principal, the amount deposited or the amount borrowed. R is still your interest rate written as a decimal, and it's an annual interest rate. The T is still the time and the time in years. The N is new. The N is the number of times the interest is going to be calculated in a year, the compounding period. So compounded N times per year. That's the new piece right there. I usually use this formula, but in order for you to enter this correctly on your calculator, before you type it in, you'll want to go ahead and multiply the NT. The NT is how you figure out the total number of periods that throughout the whole length of the loan that they're going to calculate interest. So that's what the M means, and you will be doing that, but I don't really remember the M formula. I just think about this one right here, and I just multiply the N times T when it comes time. All right, let me show you what I mean by that. So if we want the future value of the 8,560, if it's deposited in account paying 4% compounded quarterly for 8 years, what we would do is this would be our P, okay? Our R would be 0.04, that would be R, okay? Compounded quarterly would mean that the number of times in 1 year they would compute the interest is 4 times, and T would be 8, okay? So we just plug into that formula. So A would equal the principal, 8,560, times 1 plus the interest rate as a decimal, divided by 4, and then that, close that parenthesis, that has to be raised to the 4 times 8 power. Okay. So I usually just type this into my calculator, but when I type it in, I do pretty much what you see there, the parentheses. Some of you have calculators that give you syntax errors if you don't actually put the multiplication symbol, so you may want to do that. But then I can type in plus 0.04 divided by 4, close the parenthesis, raise to the, and then don't put 4 times 8. If you did, you'd have to have it in parentheses. Just go ahead and work that out and say to yourself, oh, so that's 32, and put a 32 right there. If you do that and then hit enter, okay, you'll find that that would be about $11,769.49. Okay, we're dealing with money, so it's pretty standard to round it to the nearest hundredth. Okay, so that's kind of a direct use of the formula. You know, if this problem were months instead of years, you'd still have to do that same conversion we did before. You do have to think about what to use for the N. And I do want to comment that I didn't notice it until I started doing the video. The 4 that you see here is because of it being compounded quarterly. If the interest rate had been 6%, if this had been a 6%, it would be the interest rate that changed to 6%. It would still have a 4. The n would have still been 4. Okay. So that's just a coincidence that you had a 4 here. And then it was quarterly and you had a 4. All right. All right. On number 5, we're reversing the process. So we're starting with knowing how much we want to have after a certain number of years. So what amount do we need to deposit today at 5% compounded monthly so that it will grow? It will become 18,000 in 20 years. You do this kind of thing if you're trying to like save money for a wedding or trying to save money for your kids to go to college or something to that effect. So the 18,000 goes in the future value place. We don't know P. We're going to figure that out. We do 1 plus the interest rate as a decimal, 0.05, compounded monthly, so N would be 12. So we divide by 12 there, and then we raise this to the 12 times 20 power. This needs to be worked out before you enter it, do anything with it in your calculator. Okay. So I could divide both sides, couldn't I? By the 1 plus 0.05 divided by 12 raised to the 240. This would equal 240. Okay. I could do that. Okay. 18,000 divided by all of this. And if you're having trouble with this, you could figure out what this is in the denominator. Just don't round too much. Keep a lot of accuracy and then take the 18,000 divided by it. I normally do type it in like this: 18,000 divided by 1 plus 0.05 divided by 12, close the parenthesis, raised to the 240th power. Okay. And then I get the answer. And it turns out to be about $6,635.60. Okay. All right. So that would be my answer there, rounded to the nearest hundredth. Okay.